In this lesson, we're going to learn about derivatives of natural exponential functions. Now, we know that the natural exponential function, e to the x, comes from, we talked about this function right here, it's given f of x equals 1 plus 1 over x raised to the x. If we have the limit as x approaches infinity of f of x, with f of x being this function right here, that is equal to e. And then if we take that e and raise it to the x power, we have the exponential function. So the exponential function, f of x equals e to the x, is the one that we're going to be working with, and we're going to talk about its derivative. Now, this right here is pretty darn cool. So this is cool stuff. It's pretty neat. What's even neater, though, is that the derivative of e to the x is e to the x. That's even cooler. So even cooler than where e comes from. So here's our rule. We're going to have two of them. We're going to have the derivative of e to the x is equal to e to the x. It's a pretty important rule and a pretty cool one. And we're also going to have the chain rule, where we have the derivative of e to the u is equal to e to the u times du dx. And this right here is the chain rule. So let's get to our first example. Our first example says find the derivative of f of x is equal to e to the 2x. So this right here, we're going to need to use our chain rule. So we're going to need to use e to the u. So if we use e to the u, that means that u equals 2x. And du dx is equal to 2. So using our rule here in orange, the derivative of e to the u, f prime of x, is going to equal e to the u times du dx. And e to the u is e to the u, and du dx is 2. And then our last step, I apologize for that, our last step is to substitute back in. We have to substitute this back in because we want it in terms of x. So f prime of x is equal to e to the 2x times 2, which is equal to 2 times e to the 2x. Now that's a lot of work to perform the derivative for such an easy function. So let me show you in my own words how we're going to do this. Sometimes we are going to have to go off to the side and say, okay, let u equal 2x, and then du dx equals 2. And you're going to say the derivative of e to the u is e to the u, which would be e to the 2x, times the derivative of the inside, which is 2 e to the 2x. So sometimes we're just going to use the chain rule, but it's going to be helpful on other problems if we can write down what u is, if u gets to the point where it's a little bit more complicated. So we'll continue to practice. forgot. I'm writing all of this down, which is a good thing. So here's another example. We want to find the derivative of f of x equals e to the negative 3x squared. So the derivative is going to be the same thing, e to the negative 3x squared, times the derivative of the exponent. And the derivative of the exponent is going to be negative 6x. So I rewrite that, negative 6x e to the negative 3x squared. That's how we would write that. And part of this is just learning how to write your answer. Like, do you write the x before the base e? And yes, I write x before I write base e. Okay, here's another. F of x equals 6e to the x cubed. So we're going to have f prime of x is going to equal the same function, 6e to the x cubed, and then we're going to need to find the derivative of the exponent, and the derivative of the exponent is 3x squared. So our final answer is going to be 6 times 3, which is 18, x squared e to the x cubed. So that's an exponent to an exponent. It's kind of interesting. It's pretty interesting. I think it's pretty interesting. Okay, here's one for you to try. F of x equals e to the negative x. Okay, let's see if you can get that answer. Press pause and then come back and check your answer. And our answer is, if you got negative e to the negative x as your answer, give yourself a pat on the back. Say hot dog, you got it. Okay, in the next video we're going to explore finding the derivative using the chain rule that we've been using, but combining it with the product rule and maybe even the quotient rule. You know, whatever rules we have to this point, we can start using together.